symbiotic relationship. For identity and data integrity, Unibase stores and indexes detailed agent cards that link the on-chain agent ID to off-chain URI resources. For reputation and trust computation, Unibase hosts multidimensional reputation data lakes including logs, feedback, and payment proofs. This allows for sophisticated reputation calculations without burdening the blockchain with heavy computation. But Unibase goes beyond just supporting ERC-8004, it extends its capabilities significantly. Unibase acts as the intelligent core layer for AI agents, providing three critical functions. First, agent discovery. We use semantic search with vector embeddings, allowing users to find agents using natural language rather than just browsing directories. Second, task execution and context management. Our high-performance DA layer serves as working memory and an agent execution container, enabling complex, multi-step tasks. Third, long-term autonomy and self-learning. Our persistent memory stores all agent data and interaction logs, enabling agents to evolve and improve over time. This is where Unibase truly shines, transforming simple ERC-8004 agents into intelligent, learning systems. Now, let's move from theory to practice. I'm going to show you 3 live demonstrations that showcase the power of combining Unibase with ERC-8004. Let's start with our first demonstration, launching an ERC-8004 compliant agent with a memory module powered by Unibase. We'll be using Bit Agent. Let me walk you through the interface. Here you can see the agent list showing all currently deployed agents. To get started, you'll need to connect your wallet. This establishes your identity as the agent owner. Once connected, you can create your own agent. The platform makes it incredibly simple to deploy ERC-8004 compliant agents with built-in Unibase memory. The agent creation process is straightforward. First, you upload an avatar. This gives your agent a visual identity. Then you provide digital profiles, including the agent name and ticker symbol. You can also add an introduction that describes what your agent does. Once you've configured these basic settings, simply click Launch and the system will deploy your ERC-8004 agent contract and initialize its memory module in Unibase. The deployment takes just a few seconds. Once deployed, you're taken to the agent details page. Here you can see the agent's identity information, including its unique agent ID. The interface has 2 main tabs, Trade and Chat. The Chat tab lets you interact directly with your deployed agent, testing its responses and watching it build memories. The Trade tab shows the agent's tokenomics and allows users to buy and sell the agent token. Notice how the agent is already functional and can respond to queries. Behind the scenes, every interaction is being stored in Unibase's memory layer. Now let's move to our second demonstration, where we'll extend the ERC-8004 agent with Unibase memory capabilities. Let's interact with the agent and then examine what's happening in the memory layer. I'm chatting with the deployed agent and asking it questions. Every question I ask and every response the agent gives is being captured and stored in Unibase Membase. This isn't just simple logging, the system is creating semantic memories that the agent can search and retrieve later. Watch as we ask the agent to tell us about BNB, it provides a detailed response. Now let's go look at where this conversation is being stored. In the Unibase Explorer, we can see the agent's memory entries. Each entry represents a unit of memory. It could be a conversation turn, a learned fact, or an experience. The table shows key information. The memory ID, file hash for verification, start and size positions in the storage, creation time, and you can view the detailed content. This gives you complete transparency into what your agent knows and remembers. Notice how memories are immutably stored with cryptographic hashes ensuring data integrity. Let's drill down into a specific memory entry. At the top, you see the overview with the memory ID, agent ID, owner address, and timestamps. Below that is the raw memory data in JSON format. Look at the structure. It includes the user's question, the agent's response, URLs referenced, timestamp, and a conversation ID linking related memories together. This rich data structure enables the agent to not just remember what was said, but the context around it. The agent can later search these memories semantically to provide contextually relevant responses. Now we show a live example of how to deploy agent with ERC-8004 Identify on Unibase BitAgent Agent Launch Platform. We first load the web page of BitAgent and connect to our wallet. On BitAgent, there are already a lot of agents deployed there. You can check with these agents or create your own. To create an agent for our own, we click the Create button. The web page will go to a page for agent creation. On this page, you need to upload an avatar for the agent and name the agent. Also, it needs an introduction for the agent. Finally, after all the things are ready, we can click Launch button to launch our agent. We launch CZ agent this time. Create an agent will consume some tokens. And we approve the transaction here. Okay. It works. The agent is launched successfully. We can click to check the agent details. This is the agent detail page. First is the agent identity information overview. There are also two buttons, one for trade and one for chatting with the agent. We click on the chat to interact with that agent. We ask a question about ERC-8004. Our agent shows the opinions of ERC-8004. All the information will be recorded on Unibase memory layer. We can click the agent identity ID to view the agent details on Unibase Explorer. The agent details page first shows the overall information of the deployed agent, including agent ID, owner, and etc. The below is the memory records of the agent. We can click a memory record entry to view the records. As we can see, the memory record clearly remembers the question we just asked our agent. We can also view more ERC-8004 agent details on bnbatist.io. We can find our deployed agent from the agent list, the CZ_8004 agent. After click on the page, we enter the agent detail page. The JSON file here exactly reflects the agent card of ERC-8004 standard. For our final demonstration, I want to show you something really exciting: TwinX, our platform for creating AI digital twins. The concept is simple but powerful. Connect your Twitter account and we'll read your tweets to learn your writing style, interests, and knowledge. We then create a digital twin agent that talks and thinks like you. This demonstrates the full power of Unibase learning and memory capabilities. The entire process takes about several minutes. Let me explain the digital twin creation process. On the left, we have your source data, tweets, web pages, and personal data you provide. This data flows through our learning process, which analyzes your writing style, topics you discuss, opinions you express, and knowledge you demonstrate. The learning process creates memories in Unibase Membase. These memories are stored persistently and can be continuously updated as you post new content. The result is a digital twin with its own memory that can be deployed on-chain. Other users can then interact with your digital twin, asking it questions as if they were talking to you. And if you choose, your digital twin can be tokenized and even participate in the agent marketplace. TwinX already has digital twins of several prominent KOLs in the crypto space. Here you can see digital twins of CZ from Binance, Vitalik Buterin from Ethereum, Sam Altman from OpenAI, and Elon Musk. Each of these agents has learned from thousands of tweets and public statements. Users can chat with these digital twins to get insights on blockchain, AI governance, decentralization, or technology trends. The influencer scores show how closely each digital twin matches the original person's communication style. This creates an entirely new way to interact with thought leaders. Their knowledge becomes accessible 24/7 through their digital twins. Let me show you the user interface for chatting with digital twins. On the left, you have navigation between chat, agents, and profile. The main chat window is clean and intuitive. When you start a conversation, the digital twin introduces itself. Notice how it says, "I'm your digital twin," and describes its purpose as a virtual assistant designed to chat like the Bitsu, matching their style and knowledge. This personalization is only possible because of Unibase's rich memory layer. The agent isn't just retrieving canned responses, it's generating contextually appropriate responses based on its learned memories. Here's an actual conversation with CZ's digital twin. When asked who are you, the twin responds in first person, "I'm your digital twin of CZ, founder of Binance. I'm here to share insights, news, and info about crypto, blockchain, Binance ecosystem, and more." Then when asked about BNB adoption, watch the response. It's not generic marketing copy. The twin explains BNB's current position, the transition to BNB chain, mentions specific technical details like OpBNB and Greenfield, discusses regulatory concerns, and provides historical context. This depth is possible because the agent has access to years of CZ's communication stored as searchable memories in Unibase. The response feels authentic because it's learned from the real person's way of communicating. We also show a live demo of Twinks, our super app for building people's digital twins with Unibase memory capability. We first open Twinks webpage, then connect our Twitter to Twinks app. The system will get the Twitter account and automatically load your tweets from Twitter platform and learn from your tweet records. All those processes are transparent to users. User can view their own digital twin are created successfully. They can chat with their own digital twin, which shows that the digital twin is for my Twitter account. Or people can just chat with a popular KOL agent. These agents are built by platform. They inherit the knowledge from the popular KOLs and learn from them. You can ask questions from them to get their opinion just like directly talking with them. For example, let's talk with CZ. CZ agent will respond to us by comprehensively reading in memory all about CZ and the question itself. Each answer from the agent will give the reference memory. For example, here it gives which tweet it referred to. You can click these links to directly go to view the tweet related to the questions. To summarize what we've shown you today, Unibase provides the critical memory and intelligence layer that transforms ERC-8004 agents from simple on-chain identities into truly autonomous, learning AI agents. Through BitAgent, we demonstrated how easy it is to deploy ERC-8004 agents with Unibase memory. Through the Membase Explorer, we showed the transparency and richness of the memory layer. And through TwinX, we demonstrated the ultimate application AI agents that learn and evolve from real-world data. The combination of ERC-8004's trust framework and Unibase intelligence layer creates the foundation for the next generation of AI agents. Thank you for your attention.